Let's take a look at these dilution problems. Dilutions are a slight variation on the molarity problems, but we have two different situations, or a beginning set of conditions and a second set of conditions. This is the formula that we're going to be using for dilution, which means for the first concentration multiplied by the first volume has to equal the second concentration times the second volume. This means if I have a concentration in molarity and I multiply it by volume, that gives me the number of moles. So number of moles in my first conditions have to equal the number of moles in my second condition. This makes sense because the number of moles don't change when I dilute something. I don't add any more of my solute. All I'm doing is changing the volume typically. And so the number of moles remains the same, and that is the basis for this equality. So the first concentration multiplied by its volume has to equal the second concentration multiplied by its volume. Let's take a look at a couple of problems to kind of help us see, or help it explain a little bit what this actually looks like in real life problems. What is the concentration of the NaCl solution that results when 0.15 liters of a 0.556 molar solution? So I have V1 is 0.15 liters, and I have M1 or C1, either or. But some textbooks have C and some textbooks have M. So C1 is equal to 0.556 molar. This is allowed to evaporate until the volume is reduced. So my volume 2 is now 0.105 liters. So I'm going from 0.15 to 0.105. The hardest thing about dilution problems is figuring out which volume goes with what concentration. But this was my initial set of concentrations, and I'm asked to figure out C2, the last concentration. Okay? These two were given to me first, and then I made a change. I reduced the volume, and now I need to figure out the concentration. Now, once again, if I reduce the volume, that will increase my concentration. So let's see if we get the correct concentration. So we have C1 V1 is equal to C2 V2. Now I want C2, so I divide both sides by V2, and that isolates my C2. Now make sure you plug in the correct numbers. My C1 is 0.556 molar times C1 or V1 is 0.15 liters. Divide that by 0.105 liters. Now notice that because we've got two terms of volume on either side, it's not necessary to always convert from milliliters to liters. Now it will be if we are asked to figure out molarity, if we don't have it, but in this case, because we're multiplying and dividing by the same unit, so I don't need to convert all of them to liters or all of them to milliliters. If they're given, I have to make sure that both my volumes are in the same unit with each other, but not necessarily in liters all the time. So these will cancel, leaving me with molarity, which is what I needed, and that should give you 0.794 molar. And as you can see, it's a little higher than my original molarity, which makes sense because the volume went down, which means the concentration will go up. These two are inversely related to each other. When one goes up, the other has to go down. And therefore, I have done this calculation correctly. Let's take a look at the next problem. An experiment in a general chemistry laboratory calls for a 2 molar solution of HCl. So I want a 2 molar solution of HCl. How many milliliters of 11.9 molar HCl would be required to make 250 milliliters of 2 molar HCl? Now notice I want 250 milliliters of 2 molar HCl, not of 11.9 molar. So my C1 is 2.0 molar, and the volume, so V1, is equal to 250 milliliters. My C2 then, my second concentration, is 11.9 molar. Now note this could have been C1 and these would have been C2 and V2, but you have to make sure you understand which concentration and which volume goes together. It doesn't matter if that's C1 or C2, it matters that the pair goes together. And I am asked to figure out the volume. Okay, let's start by using my formula. C1 times V1 equals C2 times V2. I'm asked for V2, so I have to divide with C2 both sides. Okay, now I have isolated V2. Let's plug in the numbers. C1 is 2 molar times V1 is 250 milliliters. Note that I'm not changing it because I will end up with milliliters, which is okay. And then C2, 11.9 molar. My molarity will cancel here. And if I do that calculation, I should get 42.02 milliliters. And that's my answer. Once again, let's take a look. This concentration is higher than this, and therefore this volume is going to have to be lower than that, right? If I increase the concentration, I lower the volume. And that is how I know that I've done this calculation correctly.